Alright, so we're now going to do the second half of the laws of exponents, laws 6 to 9. As a reminder, what an exponent is, we have a base and we have an exponent. The base is the number that we're constantly multiplying, the number that we're repeatedly multiplying. The exponent is how many times we're multiplying. So we're starting with a 1. The base is 3, and we multiply it 4 times. 1 times 3 times 3 times 3 times 3. And that is 3 to the power of 4. We also did the first 5 laws of exponents in the first video, and we're going to use that to help us derive the next 4. Okay, so before we even do anything, I'm going to say something that's really obvious. 0 is a special number because anything minus itself is 0. If I have 1 cupcake and I subtract 1 cupcake, I eat it, I have 0 cupcakes. 0 equals 1 minus 1. And 0 equals anything minus anything, or anything minus itself. We're going to stick with 1 minus 1. We're going to stick with that equation. Okay. Law number 6. What happens if we have 3 as our base, and my exponent is 0? 3 to the power of 0. So a lot of students say, oh, that equals 0. 3 to the power of 0 equals 0. But that's actually not true. I'm going to use this. 0 equals 1 minus 1. So 3 to the power of 0 is the same as 3 to the power of 1 minus 1. I'm replacing the 0 with 1 minus 1. Now I'm going to look at my past laws of exponents. I know that if I have an exponent, something minus something, I could put the second exponent to the denominator, which is what I'm going to do. So now this becomes 3 to the power of 1. And this negative 1 here, I'm going to bring it to the bottom. 3, and instead of this being negative 1 at the bottom, it becomes a positive 1. 3 to the power of 1 over 3 to the power of 1. We have one number over itself. Whenever we have that, it cancels. They cancel each other out, and the solution is just 1. So 3 to the power of 0 is not 0. In fact, 3 to the power of 0 is equal to 1. And anything to the power of 0 equals 1. That is law number 6. 3 to the power of 0 equals 1. Any number, any non-zero number to the power of 0 equals 1. 0 to the power of 0, actually, there's a lot of debate. A lot of mathematicians don't agree with what 0 to the power of 0 is. But anything else to the power of 0 always equals 1. All right, law number 7. Now let's say we have 3 to the power of 4. And we're going to take this 3 to the power of 4, and we're going to take the whole thing and raise it to another power. We're going to raise it to the power of, let's say, 2. 3 to the power of 4, that whole thing to the power of 2. So what the heck could that mean? Well, let's use PEMDAS. We're going to do the stuff inside the parentheses first, and then we're going to do the rest. 3 to the power of 4. I wrote it up here. It's 3 times 3 times 3 times 3. So I have 3 times 3 times 3 times 3. And right here, and I did this 4 times. Remember that we expanded this 3 to the power of 4, but that's still raised to the power of 2. The whole parentheses is raised to the power of 2. So I'm not going to forget to write that. I'm going to bring that over. So I have 3 times 3 times 3 times 3 on the inside. Everything is raised to the power of 2. Now right here it gets a little bit interesting. So this power of 2, that means this whole thing needs to be repeated twice. So I'm going to repeat this whole thing twice. So I'm going to rewrite 3 times 3 times 3 times 3. Remember, that is 4 times. And this power of 2 means I'm going to repeat it twice. So I'm going to do it again. 3 times 3 times 3 times 3. And this is again 4 times. So if you can count how many 3s there are 8 3s. And that is because we have 4 times twice. So in other words, in total, we have 4 times 2 times, or 8 times. Oh, oops. Sorry, class, forgot to silence my phone. 4 times 2 times. So, how many 3s are there? There's 8 3s, or in other words, 4 times 2. So, I did not give myself enough space. This becomes 3 to the power of 4 times 2. In other words, I multiply them. And that is law number 7. If I have 3 to the power of 4, and that whole thing, the whole is put in parentheses and raised to another power, that is the same thing as saying we take the base and we're just going to multiply those two numbers together. All right, law number 8. Law number 8 is, let's say we don't just have a 3 anymore. Let's say we have 3 times, I don't know, 4. Now let's say 3 times 2. 3 times 2, and that's raised to the power of 4. Okay, 3 times 2 to the raised to the power of 4. This to the power of 4 means I'm going to repeat this multiplication 4 times. So I have 1, 2, 3, 4. Remember, this little 4 represents I'm doing this, multiplying this 4 times. Multiplication is commutative. Commutative means I can rearrange in any order and then maintain it's going to be the same answer. So I'm going to rearrange all the 3's and 2's so they're next to each other. So 3, there I see 1, 3, 2, 3, 3 3's, 4 3's. I'm going to put them to the left, 3 times 3 times 3 times 3. I see 1, 2, another 2, another 2, another 2. I'm going to do the same thing here, 2 times 2 times 2 times 2. I just move all the 3's to the left, all the 2's to the right. Since we're doing multiplication, I could do that. Note that there's 4 3's that being multiplied 4 times. So that's the same thing as writing 3 to the power of 4. And also note that there's 4 2's being multiplied together. So that's the same thing as writing 2 to the power of 4. Whenever I have an exponent, and in the parentheses there are multiple bases, I can almost distribute the 4 among all the stuff inside the parentheses. It's kind of weird saying the word distribute, but that's essentially what we're doing. Law number 8 is if I have a product of 2 numbers, let's say 3 times 2, and that's raised to a power, let's say 4, that's the same thing as distributing the 4. 3 to the power of 4 times 2 to the power of 4. All right, one more law. We're almost there. Okay, it's kind of similar. Let's say we have a fraction on the inside. 3 over 2 to the power of 4. What if we have a fraction now? Okay, well, I'm going to do the same idea. this 3 over 2, the exponent is 4. I'm going to multiply it 4 times. So 1, 2, 3, 4. 3, 3, 3, 3. All right, 3 halves and 3 halves. Oops. I know if I don't keep the colors the same, you guys in class are going to tell me. Okay, so this is 4 times. Because we're multiplying fractions, I can multiply all the numerators together and all the denominators together into one fraction. So on the top, it's 3 times 3 times 3 times 3. In the bottom, 2 times 2 times 2 times 2. And since we're talking about exponents, I'm going to write this in exponent form. How many 3's are at the top? 1, 2, 3, 4. So this I can rewrite as 3 to the power of 4. And how many 2's are in the bottom? 1, 2, 3, 4. I can rewrite this as 2 to the power of 4. So we have the same idea as Law 8 of distributing the exponents. Here we've proven that we can also do it if we have a fraction. We could do it in the numerator and the denominator. We have a fraction on the inside. I'm distributing the 4 to the numerator and to the denominator. So whenever we have a fraction, let's say 3 over 2, and that's raised to the power, let's say to the power of 4. That is the same thing as distributing the exponent. So I have 3 to the power of 4 over 2 to the power of 4. And we are done with the 9 laws of exponents. All 9 are on this side of the whiteboard.